Hey y'all, this video is on interpreting the results in Jamovi for a dependent or a paired samples t-test. And so here you can see the results from Jamovi. And first, I just want to point out that we have this set to a one-tailed test. And so again, what we're doing is we're looking for a specific difference. We expected in our hypothesis to find that test scores on this statistics test would increase after a meme intervention. So it's the same students at both time periods, pre-test, post-test, and we're looking to see if those scores significantly changed and were larger at the second measurement. So did they score better? Was it an effective intervention? So here, this one-tailed test, the way it's set up is that if it's negative, if we're looking for less than 0, that means we expect the first score, which is the pre-score, to be lower. So now, how we interpret this. I always like to ground myself in the descriptive statistics. It's also a good way to make sure you didn't make a mistake. So if you, let's say that you looked at this and you saw, okay, pre-statistics test is 64-ish, post is 72. And then if your p-value is over 0.5, that means you set it to the wrong direction. Not 0.05. If it's over 0.5, that means that you have set your hypothesis to the wrong direction. So this is a good place to start and kind of look at that information. We also have the sample size. Now the sample size is going to be the same because we have the same number of people here. So we have pre-statistics test, we have 35 people. Those same 35 people completed the post-statistics test. And then we have the mean. So again, the mean for pre was about 64. The mean for post was about 73. So descriptively, there's a difference here, but we need to look at our results for the test to see if we think we have evidence that this might be a meaningful difference in terms of, do we think that this was just sampling error, we just happened to find a difference, or do we have evidence that this might be real, that it's unlikely that we would get this by chance? So here you can see the results, and the first one is our t statistic. So again, we would report this t statistic. It's negative because the value is negative. The way this is calculated, this is the difference between the means, and it's in terms of how much variation there is or estimated error there is. And so this calculation is adjusted for your sample size. If I had a larger sample size, my t-test would be larger, most likely, unless they had all sorts of different responses. But imagining that they had about the same kind of change as the rest of the people in this data set, we would expect that our test statistic would actually be a bit larger. And you can see that by looking at a t-distribution. If you have a table with t-scores and degrees of freedom from previous stats classes. So our next step here is we will also report our degrees of freedom, which for a dependent or a paired samples t-test where we're looking at the same people at 2 different time points, would be degrees of freedom and n minus 1. So sample size of 35 minus 1 gets us 34. Our p-value, we can see that the p-value is 0.04 if I'm rounding to 2 numbers after the decimal. This means that we're going to reject the null hypothesis. And so this provides evidence to support what we believe to be true, which is that the post-statistics test was higher after the meme intervention. Now, this is not talking, we're not saying that this is proving anything. We're not talking about there could be other causes of this change. So you don't want to go too far with your information. We just have some evidence that there was a change and that it was an increase in scores. Now this next part here, this is our mean difference. So this is actually the difference between the two groups or the 2 time periods of measurement. And then this is our confidence interval. So our confidence interval, it's a way of basically reporting the like the range of likely values for the true difference. So it's a little bit it provides kind of different information, whereas the p-value is talking about our likelihood of getting our specific sample or a more extreme sample if the null hypothesis were true. The confidence interval kind of tells us like, hey, likely values maybe fall between here if we're looking at real differences. And so you can see that the lower part of it is this negative infinity. That just means that it's the lowest difference possible. And then the upper boundary is only 0.64. So it's telling us that one of, a likely value of true difference is like less than a point on a statistics test. So that right there kind of tells us like, maybe it's statistically significant, but do we really care? Probably not. I mean, it depends on how much effort this meme intervention is, right? Um, Next, we're going to look at the Cohen's d. Cohen's d is our effect size, and this is the size of the difference between the time periods in terms of standard deviations. This is another way, again, of assessing the same information. And this is descriptive. It's talking about in the sample. The size of the difference between groups is quite small. So according to Cohen's guidelines, zero point 0.3, positive or negative zero point 0.3 is small. So it's statistically significant. We think that maybe this represents a real difference in time periods, but does it matter? Probably not. So that's how we would interpret those results. In the next video, I'll talk about how to write about this in APA style for kind of the most basic format. And then that will be it for dependent and paired samples t-tests.